Okay, last week we stopped at lesson number 19. It's about the energy, conservation of energy. So before we continue, we recall a bit lah, okay? So boys and girls, here conservation of energy say that the energy cannot be created or destroyed. It only can be transformed from one form to another form. So total energy remains constant in the system. Okay. So at here we have to study. Initial is what energy. After that is what energy. Okay. So for example, this example, 1 kg of block moving down. Moving down, that means that initially is at certain position. So starting is GPE. Okay, so frictionless means that no frictions. So that means that the total energy at here will be totally convert to here, last part. Okay, so what is the last part at here? Last part at here is no longer have any height. The position is actually at the lowest position. So at here is all kinetic energy. If let's say this question they change, moving down a rough surface, okay, rough surface, that means that they will have some friction. So which means that here this part, let's say this is 10 joule. So they might have some losing to the surrounding due to the friction. Because when there is a friction, they will have others energy such as thermal energy. Okay, so maybe at here it's become 2 joule. Loss to the surrounding is 2 joule. If let's say this is a rough surface. Okay, then at the end comes to here, how many joule? We get 8 joule. Okay, the rest of the energy will be 8 joule comes to the position R. So we still conserve the energy, conservation of energy, we still obey. Okay, why? 10 joule is equals to 8 joule plus 2 joule. Okay, it's equals to 8 joule plus 2 joule. The 2 joule is lost to the surrounding because of the friction. They have some work done to overcome the friction. Okay, so we need to read the question and then we need to identify what is the starting initial energy. Then in between the process, is there any losing? Okay, is there any air resistance, friction, and so on? Okay, if no, all the energy at starting will be convert 100% to the output here. Okay, if yes, then we have to find out how many losing, and then the rest going to the last position R lah. Okay, so this question we already done. That day we stop at question number 2. Okay, so right now we continue with question number 3. Okay, until here, is it okay? Okay, here a ball of mass 1.2 kg is dropped from a height. Okay, so that means there is a block drop at a height. So at here, the height at here is 30 meter. So at here, the height is 30 meter. Okay, as it falls, 25% of initial GPE is transferred to the thermal energy. Okay, so at here, as the falling process, okay, 25% losing to the surrounding and converted to the thermal energy. So at here, the reason maybe is the air resistance. Okay, there is air resistance. So you write it down lah. If in the structure question, they might be asking you what is the reason why there is losing of the energy. Okay, and the energy of GPE converted to the thermal energy. Okay, so the reason is air resistance. Okay, then after that, set 25 is goes to the thermal energy. That means that the rest is how many? The rest is 75%. Am I right? The rest will be converted. The rest at here, this one is kinetic energy. Okay, just before it hit. Okay, it's kinetic energy. So this one is 75% of starting GPE. Then 25% lost to the surrounding as the thermal energy. 25% of GPE. Okay, actually converted to the thermal. So starting is GPE. Okay, so boys and girls, how you are going to solve this question? Can you try? Can you try to solve it before I give you the answer? Okay, can you calculate starting GPE? What is the GPE? Initial energy. Then after that, you times with 75% of the answer. That is the kinetic energy. If you want to count the 25% of thermal, also can. But after you do calculation for the thermal, this is the losing. So you still need to need your initial GPE value minus the answer of the thermal. Then you only can get GPE. So if you understand the concept, you can just using the GPE that you get times 75%. That's all. Okay, can you try? At the same time, I'll take some attendance. If you already tried, then please type the answer in the chat box. This Saturday, we got replacement class. Don't forget, 8 p.m. Okay, so you complete the question number 3 and then tell me the answer. Fetch number 6. Any of mass is 1.2 kg. G is not given teacher, but you have to know. This value we have to know by ourselves. This is 9.8. Then H is the height. So they tell you that drop from a height of 30. So this one is 30. So for my answer at here, I will get 352.8 joule, right? Do you able to get the same answer? Then at the end, kinetic energy is 75% of the GTE. My answer is here, I get 260 joule. Do you able to get the same answer? Okay, give me some reaction so that I know that whether you're able to do it or not. If yes, then we can continue for the next question. Angeline, okay. How about others? Crystal, Hui Tong, Licious, Zihua, Teresa, okay. Okay, so this question solved. So we goes to question number 4. Okay, next question. This is 2023, November exam paper. A girl holds a rubber ball out of the window of a tall building. Oh, this one, diagram is here. Okay, the mass of the ball is 0.20 kg. The ball is at rest 10 meter above. Okay, so all is drawing at here. This one 10 meter. Okay, the height is 10 meter. Calculate the GPE of the ball relative to the concrete path. Okay, easy, very straightforward. Please, formula, substitution, final answer. Okay, do it right now. Crystal. Yes. Yes, Crystal, yes. Unit, remember unit? Yes, you got unit. Angeline, yes. Okay. So that means that it's very straightforward. So we can just here 0.2 times 9.8 times the height is 10. So you guys give me 19.6 joule. Or two significant figure is 20 joule. Okay? Or 19.6 two significant 1, 2. 2, then we found out that the 6 can be add 1. So it's become ball before, immediately before it strike the path is 14 meter per second. Speed of the ball immediately after it strike the path is 12 meter per second. So calculate the kinetic energy of the ball immediately after it strike the concrete path. Okay. So starting is what energy? When the ball falling. So when the ball falling, what is the energy? Starting energy. Then after that, what energy in convert? Kinetic energy of the ball. Immediately after it strike the concrete path. Okay, calculate the kinetic energy. Calculate the kinetic energy. Wait, okay, you try first. Oh, okay. This one is calculate the kinetic energy. Surely didn't asking you to convert because all the quantity, all the physical quantity is given. So this question actually no need so complicated. Kinetic energy is 1 over 2 mv square. Okay, 1 over 2 m. M for the ball is 0.2. So at here 1 over 2, 0.2. Okay, speed that also provided. So that means that we don't need to do conversion. Okay, we don't need to do some conversion of energy. So we can straightly get the answer by using the information provided. Speed of the ball immediately after. So at here is after. Then here after. So we are using this. After is 12. 12 square. That's all. Okay, that's all. So you can just using this to find the answer. Okay, if you do calculate, if you calculate correctly, so it should be like 14 joule, if not mistaken. Okay, so this question no need conversion, no need conversion, because all the information they provide already, they provide to you. Kinetic energy, they give you the m, give you the velocity immediately. 14.4 can. 2 to 3 significant figure. Okay, 2 to 3 significant figure. Okay. Then after that, this one actually is not conversion. This question is not conversion. Okay, by the way, if no question, then we are going to the page number 8. Okay, let me read your message. Angeline. Yeah, Crystal, because this one, they're very straightforward, asking kinetic energy and all the information provided. So no need to use the conversion of energy. Zhihua, okay, 14.4. If 3 significant figure, 14.4. Okay, we goes to your page number 8. Okay, here, the salmon jump up. Okay, jump up. Jump, jump, jump. So what is the initial energy? Okay, so you have to know what is the initial energy? Jump. Then After that, what is your energy after you jump above the surface of water? On these occasions, the salmon will fall back down into the river. The mass, okay, this is mass, underline, this is M. Then salmon leave the water vertically with a kinetic energy. So jumping. So starting is kinetic energy. So you jump until a certain height. So what is the energy? GPE. Okay, so starting is somewhere here. Okay, starting, the fish is here, jump. So here is kinetic energy, here is GPE. Okay? Okay, kinetic energy is 16.2. Calculate the speed of the salmon as it leaves the water. So can you do calculation? What is the V? What is the V? Angeline, correct? So how about others? Energy for kinetic energy is 1 over 2 mv squared. Energy is 16.2 equals to 1 over 2. 2 times v squared. Remember, the square is actually for v, not for others. So after that, you have to square root. Okay, square root it. So if you do everything correct, you don't copy our answer, you have to press your calculator by yourself. Make sure that you know how to use and you know that you need to put a square root. Okay, so at here, the answer is 4.02 meter per second. 4.02 meter per second. Okay, can you calculate the maximum height? Okay, by the salmon. Oh, what is your maximum height? Can you try? Maximum height related with what energy? So this is a conversion of energy. Try and then tell me your answer. You need to let me know your answer so that I know that you already complete, then we can continue. I want to make sure it's not too fast. Our study speed is not too fast. If not, you haven't tried, then I already tell you answer. Any of you? It's not a hard question, what, dear? So how did you able to get the answer? How about Hui Tong? Zihua, I think yes, but the second significant figure slightly different as me. Angeline, not Zihua, Angeline. Eh, also Then let me check. Is it my problem? My answer should be 0.83. Okay, here, maximum height. This is the energy they gain, which is the GPE they gain. Okay, they must have something energy losing, some form of energy loss, and then this one GPE they gain. So at here, kinetic energy is lost. Okay, then it converted to GPE. GPE is gain. Okay, so this one, kinetic energy. What is the kinetic energy? Maybe I think why you didn't get 0.83 is because you're using 1 over 2 mv square about this one, right? That's why you got a bit different as me. Okay, for me, I straightly using 16.2. So just now 4.02 actually is already we round off. But if you show it clearly, should not be a big problem, okay? So here This one is 16.2. 16.2 is my energy, kinetic energy. I think the difference is here lah. But if in the exam you show the examiner equals to mgh, 1 over 2, the m is, I can't remember, is it 2? Yes. Then v is 4.02 squared. Should be no problems, okay? Because your idea and the value that you substitute is correct. Okay, but if using my 16.2, then this one maybe I can write kinetic energy, then mgh 16.2, m is 2, g is 9.8, h I don't know. So my h is 0.83 m. Okay, if you're using 1 over 2 mv square equals to mgh, then I think you will get your answer. So what is it you using the second one? Then this one 0.82 meter.
Yes.
Okay, then should be fine. Okay, here I want to emphasize there is one more method for us to do calculation for this part, for us to get the answer for this part, is using linear motion equation. Still remember or not? V equals to U plus AT, S equals to 1 over 2 U plus V times T, S equals to UT plus 1 over 2 AT square. V square equals to U square plus 2AS. This one, one of the lesson we study about this. Okay. This 4 linear motion equation can help us to solve a lot of problem. Okay. So here, if, okay, jumping. So let's say this one object going up. Okay, starting initial velocity is 4 point. So this one is U, 4.02 meter per second. Maximum height. When you goes to maximum height, after that the object will drop, right? Object will drop is because when they reach to the maximum height, their speed decrease until here maximum height is 0. Velocity becomes 0, then it drop. Okay, so this one maximum height is a velocity, final velocity is 0. Then at here, the height at here actually in our 4 linear motion equation, we can using S to represent. The symbol is S. Okay, we still need one more information, which is the G, or we say A. Object moving upwards is against gravity. So we need to put a negative 9.8 meter per second per second. Okay, why need a negative? A is negative, meaning that slow down. Okay, meaning that slow down, deceleration, slow down. So object throw upwards, the speed will decreases is because it against gravity. That's why decrease from 4 meter per second, decrease until maximum height is 0. When there is no speed at here, at the end, the object will fall down because of gravity pulling it. Okay, so look at here, UVAS. So UVA no S, so cannot. UVA no A, cannot. U no V, cannot. UVAS. Okay, we use the last one. So we can using this. Okay, V square equals to U square plus 2AS. V is 0, U is 4.02 square plus 2A, A is negative 9.8, S is the maximum height. Okay, maximum height. So at here, we do calculation. 4.02 square 2 times 9.81 times the maximum height is 4.02 square. Okay, divided by 2 divided by 9.81. So at here, answer for S is 0.82 meter. So in physics, we are not only one method to solve the question. We can have few ways to solve it. Okay, as long as you understand the concept. So for this kind of question, you can either using motion, okay, linear motion equation to solve, or you can using the energy, okay, conservation of energy to solve it. This one, actually, we also mentioned last week here, last week here. You see, I told you, okay, GP loss against to kinetic energy. From here, we also can using the linear motion equation. Actually, we're also using this v squared equals to u squared plus 2as. When object drop, initial velocity is 0. Then final velocity, we are going to calculate. Your acceleration is 9.8. Why here is positive? Because object moving downward drop. Moving downward. Moving downward, gravity pulling it, it will accelerate. Acceleration is positive. A is positive. Okay? So, we can have two ways to solve lah, okay? So this one also the same. Okay, until this question, any question you want to ask me? If no, give me reaction, then we goes to page number 9. If you got any question, then you let me know. Hui-Tong okay. Crystal okay. Angeline okay. Megan okay. Okay, good job. So we goes to page number 9. Okay. Figure 2.1 shows a track for a model car. The car has no power supply, but can run down a sloping track due to its weight. Okay. So starting at weight. The car is released at N or Q. Here. So starting at here. Then it comes to rest just before it reach to the S and roll back. That means that starting from here, it go down until somewhere here before it reach to the S, and then you come back again. Okay, roll back again. Explain in terms of energy transformation why the car starting at Q cannot pass to S. Okay, you see, Q at here and S at here is same height, what? Then why not from here, the energy that I gain, GPE, is totally going and let me achieve, comes to this position. Why cannot? What's wrong happening in terms of energy? Any of you got idea why? Perfect what? From here, 0.4 mgh. Then it go down and then comes to S. But in real life, they tell you, no, it's not. It's not comes to the point S. It's somewhere here and then roll back. Why? In terms of energy, what happened to the energy? Why the car cannot pass S? Okay, let me check, Crystal. Because of the friction. Yes, because of friction. Okay, so there is some friction, so they will having some energy loss to the surrounding. So the final energy is not equal to the initial anymore. So like what I told you just now, let's say here is 100 joule. So we lost it maybe because of the air resistance, maybe because of the friction, okay? But here is mostly moving with the track, so we say friction, okay? So let's say 100, here is 20 joule. That means that you only left 80 joule. Of course, 80 joule you cannot go to point S. If you can go to the point S, exactly the same height, that means that here the energy amount equals to this position. So since they are not reaching to the point S, must be some energy lost due to the friction. Okay, energy cannot be created, so it cannot be going higher than origin. No, friction to cause the loss of energy. First sentence, if you say so, is not correct. Energy cannot be created. This one correct. Cannot be created. So that means that it will transform to the last at last stage of energy. So it cannot going higher than origin. Why? Because of friction. If you say that cannot be created, energy cannot be created, it cannot go higher than origin because friction cause the loss of energy. Then okay. Is it possible that a surface have absolutely no friction? In practical, no. In practical, no. Okay, in real life, no. They must have some lossing. But in answering the question in the exam, they will have this kind of question. They will say frictionless. Then that means that no friction. That case is, we assume, perfect case. Okay. So for this one, in terms of the energy transformation, why cannot pass? Okay, because energy loss due to the friction. Yeah, that's all. A second car of a mass 0.12 kg is released from point P. Okay, a second car is here. Okay, going down. It continue until it run off the track at T. Okay, calculate the maximum speed. Calculate the maximum speed that the car could have at T. So what is the maximum speed at here? Okay, assuming friction in the car is negligible. That means that we ignore, for this calculation, we ignore the friction. Okay, we ignore the friction. So can you try? So at here, the energy, if no friction, that means that all the starting energy will be perfectly 100% convert to the final energy. Okay, so at here, starting, what is the energy? Ending, what is the energy? Then can you find out what is your maximum speed? Do your calculation and tell me your answer. Angeline already get the answer. Yes, perfect. Correct. How about others? Okay, so starting at point P is the energy of GPE. So GPE is mgh. Then T at here, there is at the lowest point, lowest position. So there is no GPE anymore. This is kinetic energy. 1/2 mv squared. Okay, so at here, the energy of GPE will be converted to the kinetic energy, 100% convert, because at here, they say ignore the friction. Okay, if not ignore the friction, if let's say they told you, oh, the friction is 10 joule, then that means that your eGPE, you have to minus this 10 joule only, the rest of the energy going to the kinetic energy. But here they didn't tell you and they're just asking you to ignore it, so we can ignore it. Okay, so this one is mgh equals to 1/2 mv squared. Okay, the second car of mass 0.12, yes. Okay, 0.12 times 9.8 times the height is 0.5, because right now it's talking at point P. Right now it's here point P, so the height is 0.5 equals to 1/2 9 point, not 9.8, it's 0.12 V squared. So what is your V? Okay, so I already get the answer. Okay, 3.13 meter per second. That's all. Okay, if there is a friction, so this mgh, we still need to minus friction. Only the rest of the energy going to the kinetic energy. No friction, perfectly 100% convert to the last step. That's all. No matter how they move at the between, doesn't matter. Okay, starting, ending, same. When there is no friction, perfect case. Okay, so until here, is it okay? If okay, we are going to your page number 9. Is it number 9? Hey, number 10. Okay, Crystal, okay? Hui Tong, is it able to follow? Hui Tong, okay. Okay, then dear Megan also okay. Then goes to the next page. Vertical tube contains a liquid. The metal ball is held at rest. So starting is at rest by the thread just below the surface. So here they hold it. Okay, the metal ball has a mass of 2.1 gram. Okay, so this is the mass M. It falls a distance 0.8 meter between being released and reaching to the bottom. That means that from here, okay, this one is 0.80 meter. Okay, can you do calculation for the GPE, gravitational potential energy transfer from the ball as it falls? So starting at here, the ball have GPE. Then this GPE will convert to other form of energy. So they're asking you GPE transfer. How much GPE, amount of GPE transfer to others form? So how much GPE? Okay, do your calculation. Also very straightforward. Just you need to understand the question and what formula you are going to use and using the correct value, okay? Angeline, correct. You are very good. You remember to do conversion. Okay, so boys and girls, here GPE, energy of GPE is mgh. Remember, at the end, final answer at here, unit is in joule. Joule is a SI unit, so joule is SI unit. When joule is SI unit, please make sure all this physical quantity you are also in SI unit, kg. Then this one 9.8 meter per second square. The height is in meter. Okay, so this one 2.1, 2.1. You cannot just using 2.1. You have to convert it into kg. Okay, so this one converted to the kg is we divided by 1000. Or you can say times 10 power of negative 3. Okay, G is 9.8, H is 0.80. So at here, if you do it correctly, you should get 0.016. So if you three significant figure like Angeline, it will be 0.0165. Okay, let me check. If 0.0165, two significant figure, I should get 0.017. So let me check. Oh, okay, okay. Angeline correct because the answer is 0.01646. So Angeline using three significant figure, the 4, 6. So the 6 going at 1 for the 4. So she get 0.0165 correct. If I get two significant figure, my final answer in the calculator is 0.01646 like this. So for me, two significant figure is still 0.016. If three significant figure add one more here, this 6 have to add in. So we will get 0.0165 joule. Yes. Okay. This is two significant figure. This is answer for three significant figure. Either one you can choose. 给子花 0.0165 joule. Okay. Okay, so boys and girls, next, when the ball reaches to the bottom, it has a speed 1.2 meter per second. So that means that at here, it got a speed 1.2 meter per second. It got a speed. What is the energy related with the speed? Kinetic energy. Okay, so can you calculate the kinetic energy of the ball at the bottom of the tube? Okay, do calculation right now. Angeline, correct. Kinetic energy is 1 over 2 mv squared. 1 over 2, the mass. 2.1 divided by 1000, if we convert it into kg, times V is 1.2 square. So if you do it correctly, you will get 0.0015 joule. Or we say 1.5 times 10 power of negative 3 joule. Let me check Zihua answer. Yes, correct. Okay, so dear here, teacher, you told us that this one is GPE. Just now your GPE, you do calculation, you get 0.016. 0.016 joule or 0.0165 joule lah, okay? Doesn't matter like this. Okay, after you do calculation, teacher, the value that I get for the bottom, at the bottom, the energy is 0.00015. 1, 2, 3. Okay, correct. Joule. Teacher, you're not telling us that energy cannot be destroyed, cannot be created. So it must be constant in the system, but it's not constant. Starting is 0.0165. Then right now it's only left 0.0015 joule. What is happening? So next question they're asking you, explain why the answer in this one should be A1, A and B. In A and B, oh, okay, in A is different with B. Okay, in A and B, because I modified this question, so visual numbering I didn't change. Okay, so dear, can you tell me that why? Why the GPE 0.016 joule is different from the kinetic final energy 0.0015? Any of you got idea? Let me check, Crystal. Because of air resistance. Okay, Crystal, read the question, read the situation right now. A vertical tube contains a liquid. So the metal ball is released in the liquid. So there is no air resistance, but what is that? Energy lost due to the drag force. Yes, drag force means that resistance force. Okay, drag force can be a resistance force, or Crystal, we can say water resistance. Instead of we say air resistance, no air resistance. Okay, inside the liquid is not air resistant, liquid resistant, or we say, but water, here they didn't mention this is water. So maybe we say liquid resistance. Okay, or we just say resistant also can. So this one, kinetic energy. So this one is B. Let me move it down. Okay, here, why? Is because friction or drag or resistance. All these can be accepted. Okay? Because there is a friction, because there is a drag, because there is a resistance. Energy lost due to friction, due to drag, or due to resistance. But if you write air resistance, confirm wrong, because there is no A. Oh, okay. Yes, dear. Okay, for this question, settle. Can we proceed to the page, next page? Angeline, okay. We talk, okay. Megan, okay. Okay, then let's go. Zihua, okay. Okay. Attic of mass 64 kg is bouncing up and down. At one moment, the attic is stationary. Then figure 3.1 show the attic at this moment. Okay. State the form of energy store. What energy store due to the stretching? Keyword is stretching. So when you saw stretching, what is this energy? Angeline, correct. Zihua. Zihua is called elastic potential energy. It's not elastic force. Okay, so at here, our answer can be said that strain energy, or we can say that this is a elastic potential energy. Okay, this is the energy when we compress or we stretch something and the material trying to go back to original shape and size. So when they having this elastic potential energy, they will use this energy trying to go back. Okay. So this elastic potential energy, when you saw read the question mentioning about stretching, compressing, that is the energy. Okay. So the stretched surface of the trampoline begins to contract, then push vertically upward, and she accelerates. At time t, when her upward velocity is 6 meter per second, she lost contact with the surface. Okay. What is her kinetic energy? So calculate kinetic energy. Formula 1 over 2 mv squared. Do you have the mass? Do you have the velocity? If yes, then this question can be solved. Angeline, yes, Angeline, make it two to three significant figure. Crystal correct. Zhihua correct. Okay, so at here, mass. What is the mass? 64 kg. So 1 over 2, 64 times the V is 6 square. So at here, 1200 joule, or you can say 1150 joule. Okay, in the answer scheme, they're showing this. 1200 joule. Okay, here, next question. Calculate the maximum possible distance she can travel upwards after time t. So this is time t. Okay, at time t. So velocity of speed is 6 meter per second. Maximum distance. That means that maximum height. So at here, what is the energy? You can try with the two methods. One is using linear motion equation. One is using conservation of energy. No matter which one, you will get the same answer. Angeline, is it correct? No. Let me count for you. No, Angeline, try. Try again. Any others? You get the answer or not? If using conservation of energy, starting at here is kinetic energy. So this one is GPE. So it do conversion. Okay, kinetic energy will loss and then convert to the GPE. Yes, Crystal correct. Okay, so at here energy of GPE that gain is from the energy of kinetic energy that it lost. Okay, so this one mgh equals to 1 over 2 mv squared. Okay, some of the question, they want to trick you. They even didn't tell you the mass. So if they didn't tell us the mass, do we able to solve this question? My answer is yes, we still able to solve the question. It's because the mass for the person from starting to ending are the same. Okay, it's the same. So mass and mass at here, we can cancel out. Yes, correct. We can cancel. One of the MCQ past year question, they didn't provide. They said that the durian is dropped, but they didn't give any mass. So we just cancel lah. Okay? So if this one we cancel, is it okay? 9.8 times the height we don't know. Then this one is 1 over 2 V. Oh, okay. 1 over 2, then V is 6 square. So hash is here the answer is 1.84 meter. My answer is 1.84. Maybe you're using others method. Wait, let me have a look. Yes, correct. Okay, if you're using the others methods, will you get the others answer? Okay, here mgh equals to kinetic energy. So it's here kinetic energy. So m is 9.64 times 9.8 times the h equals to this one. If you're using two significant figure, answer will be slightly different. 1200 divided by 64 divided by 9.8. So this answer will be 1.9 meter. Okay, if you're using 64, 9.8 times the h equals to 1150. H will equals to 1150 divided by 64 divided by 9.8. 1.83 meter. Okay, so these three answers are correct, can be accepted. No problems. Okay, let me check Zihua. Yeah, durian. Still remember about the durian. Okay. So no matter which method, actually it will be fine. Okay, you see, why sometimes they're using two significant figure only as in the answer scheme? It's because you see, if my answer is 1.84, two significant figure will be 1.8 meter. Here I get 1.83, two significant figure, I still get 1.8. Okay, this is the reason at the end, answer scheme, actually most of the time they are using two significant figure. No matter you using what method, slightly different with the sum value, but it's okay. At the end, you round to two significant figure, everybody will get the same answer. Okay, so this one 1.9 is because here we already round for one time to two significant figure. Okay, if you want to try v square equals to u square plus 2as, you will get the same answer for the s. The s is distance travel, actually it's our height lah. Okay, until here, any question? No, Then now is the theory part, In practice, she travel upwards through a slightly smaller distance than the distance calculated in 2. That means that I do calculation. I say that it should be maximum distance she travel upwards should be 1.8 meter. But at the end, in practice, we measure, we found out that maybe it's only 1.6 meter. It's slightly shorter distance than what we did calculation at here. Can you explain why? Why is less distance than the calculation part? Why? What's happening? Correct. Angeline, correct? Energy is dissipated through sound. Through sound? No, don't say through sound. Heat. Energy is dissipated. Yes, thermal. Yes, okay. Energy is lost to the surrounding due to the thermal energy. Crystal air resistant. Yes, crystal right now can be A. Okay, because this case is in the A. So at here, you can mention friction. You can mention air resistant. You can mention, like Angeline said, drag force. Okay, or you mentioning about the thermal energy produced. Okay, energy lost due to the thermal. Okay, so at here, they got few way to answer it. So at here, air resistance. If you want to say friction, you have to say friction with A. Okay, normally friction, we will say that is two surface, two object, two surface touching each other's. That is a friction. Okay, so at here, we mention clearly lah. Or you say drag force, yes. Okay, energy, thermal energy produced. Okay, energy loss due to the air resistance. Okay, here, maybe we say energy loss due to air resistance or friction with A or drag force. Because just now when we did calculation at here, you see, all the GPE convert to kinetic energy. What we did calculation is we make assumption that all the energy, no energy lost to the surrounding. all the GPE convert to the final kinetic energy. This is a perfect case. But in our practice, in real life, we can't achieve 1.8. Maybe only 1.6. It's because there is some energy loss. Why? Because got air resistance. Okay? So any question? If no question, we're going to the next page. Angeline, okay? How about this? Only Angeline settle? Huy Thông, okay, Megan? Sư Hoa, okay, Megan, Megan? Megan able to follow? Megan is missing. Okay, here goes to the last question. Okay, the diver climbs some step onto a fixed platform above the surface of water in a swimming pool. Okay, then after that, this is the figure show that is going to enter the water. The mass is 65 kg, platform is 8.0. Everything is here already. Okay, calculate the increase in GPE when he climbed up to the platform. When he go, standing here. Okay, how much GPE he gain? Okay, can you calculate? Yes, correct, Angeline. Yes, correct. Quite straightforward, nothing to be confused. Okay, GPE. Energy of GPE is mgh. 65 kg, 9.8. Then the height is 8 meter. So at here, if you press your calculator, mine here is 5096. So we make it 2 or 3 significant figure, we will get 5100 joule. 5100 joule. Okay, let me check. Zihua, okay, no problems. Okay, the speed with which the diver hits the surface of water, ignore any effect of air resistance. That means that no energy loss. So at here, heat. So it's here lah. So what is the energy at here? Energy of what? And then starting is standing at here. So this energy is GPE. And we did calculation for the GPE is 5100 mgh. So at the end, we get 5100. 5100, yes. Okay. Then, no air resistance. We assume no air resistance. So all the energy for the GPE will convert to the energy at this moment before enter the water. Okay, before hit the water. So you have to identify what is this energy. And then can you calculate the speed, V? Got speed. You see, got speed. Keyword speed. When you saw speed, it must be a kinetic energy. So that means that at here, this is a kinetic energy. So in GPE convert to E kinetic energy. So it's mgh equals to 1/2 mv squared. Do your calculation. Yes, Angeline, yes, correct. 65 times 9.8 times the height is 8 equals to 1/2 65 v squared. So what is your V? Zihua, unit is wrong. So ask yourself, what is the physical quantity you calculate right now? Speed, V. Speed is here, meter per second. Okay? So answer is 12.5 meter per second. So this one is we assume perfect case. There is no energy loss. Ignore the air resistance. Yes. Okay, so if no problems for this one is answer for A2. Okay, we goes to the B. which is the what we say, theory part. Okay, so this one is in another depth with the from the same platform. Same platform, that means that the GPE at here is the same lah, because this one same platform, the height is the same. Okay, but the diver doing some performance. Okay, turn, then only jump, something like that. Okay, he strengthened and then again enter the water as shown in figure. So that means that jump down, then doing some pattern performance at here and then going down. Okay, the question asking you discuss whether the speed of entry into the water. So at here, this one speed is greater, less than, or equal to the speed that you calculate in A2. So just now we calculate, we said that at here, the speed should be 12.5 meter per second. So now, this person want to do some performance, jump, and then performance, and then strengthen again, and then enter the water. So can you tell me, and you think the speed, final speed at here, it will be smaller than 12.5, greater than 12.5, or actually equals to the 12.5? Ignore any effect of air resistance. Again, they got mentioned ignore. So what do you think? Speed of entry. So just now we did calculation 12.5 meter per second. Okay, right now do performance as he fall. Then after that, strengthen again and then hit the water. So Zihua say less than. Cause of the thermal energy. No. Any others? Crystal, Angeline, Huitong? Same, because air resistance is ignored. Yes, exactly. Because at here they got mentioned ignore any effect of air resistance. That means that they will have no energy loss. So Zihua, your answer is not correct, because you say because of the thermal energy that produce. No thermal energy produced, because there is no air resistance, no energy loss to the surrounding due to the air resistance. So no. So at here, if no air resistance, no lossing to the surrounding, that means that your input equals to your output energy. So if like this, no matter what you did at the between there, actually at the end, your answer for your V, you still get the same answer. This is what? 5100. 5100 will be exactly converted to the final kinetic energy. So if you do calculation, the person mass still the same. So at the end, nothing changed. Okay, nothing changed. So at here, dear, here we write down speed is the same. Okay, why? Because 3 mark, dear, 3 mark. You always need to answer the question, refer to the marks before you refer to the mark, then you know that how many points you should write. Okay, because of what? Loss in GPE is the same. Then kinetic energy gain is the same. So of course your speed at the end still the same. Okay, another answer that accept is we mentioning in terms of force and motion. It said that acceleration is the same. They were falling down with acceleration 9.8 meter per second square. No matter, both case will be the same, 9.8. Okay, distance, therefore, is the same. Okay, so for example, like this, falling down. Another one like this, do performer falling down. Both having u equals to 0, u equals to 0. Final V. Final V. Going down 9.8 meter per second square. A equals to 9.8 meter per second square. The height at here is the same. So if we're using the V square equals to U square plus 2AS, everything are the same. Can you see that everything are the same? So let's say at here, this one is 8 meter. Let's say the S is 8 meter. Okay, so at here, your V square equals to, you see, initial is 0 plus 2, 9.8. The S is 8. Both case, the working step are exactly the same. If we want to explain in terms of force and motion, okay, in terms of force and motion, we will get the same answer at here for your final velocity. So velocity doesn't change if there is no air resistance. Doesn't matter what happened in between. Okay? So we finish this lesson and then we are going to continue next lesson. So for this part, any question you want to ask me? Zihua, where you get so many whole world looking at you. Zihua, where you get all this funny picture? Okay, dear, here, this question okay, Crystal okay. Megan, Hui Tong, Licious, able to follow? Megan okay, Hui Tong okay. Okay, if okay, then we settle with this. Actually, we finished one more chapter already. So next, we are going to the lesson number 20. So this one is about energy resources. Okay? So dear here, energy resources, we got two types. One is called renewable, another one is called non-renewable. If renewable is the resources that we can continue after we use, we still can replace and then continue use. Okay, it will not run out. Okay, non-renewable, that means that finish using, then no more already. Okay, no more already. So it cannot be replaced. Okay. Angeline. Got one more page behind. My bad. I thought finished already. Oh, okay. There is one more page. Okay. My bad. Okay. Wait. Okay, can you calculate the speed of the car at A? Mass of the car is 600 kg. At point A, kinetic energy is 160 kilojoule. So can you try? Zihua 0.73. Angeline. Okay, so kinetic energy is 1 over 2 mv square. So this one is 1 over 2 m is 600 v square. Then this one is 160,000. Okay. Don't forget the square. Zihua, I get 23. V should be 23 meter per second. How you get the 0.7 something? 730? Where you get it? Okay, by the way, here they give you kinetic energy. From the kinetic energy, we can calculate the speed because mass is provided. Okay, so I know that this one kinetic energy at here, I got 160 kilojoule. And my speed at here is actually 23 meter per second. Okay, then here, next question. As the car travel from A to B, lost 40 kilojoule of energy due to friction. So that means that at here, there is some energy 40 joule. 40 kilojoule. 40 kilojoule. Okay, 40 kilojoule. So until here, how much energy you will get at here? The question said that calculate the height. Okay, 160 energy at point B is our GPE, right? At point B. So will I get total 160 kilojoule? My answer is no. Why no? Because there is some losing. Okay, some losing. So that means that at here, I need to using 160 kilojoule minus the 40 kilojoule. Minus it. Then losing one minus, then we get the final. Final at here should be 160 minus 40 kilo. So it's 120 kilojoule. Okay. Then next, the question asking you to calculate the height h. So that's all. Step by step, solve the question and then check how to link with the question. Okay, step by step, we solve it and then find out and link with the final question asking in the question. Okay, asking in the exam. So at here, what is your H? Is mgh equals to 120 kilojoule. Kilo is times 10 power of 3. Don't forget the prefix. Not just putting the value, but you have to know the prefix. Okay, mass at here is 600 kg times 9.8 times the height equals to 120 times 10 power of 3. So your height, if you do it correctly, my answer here is 20 meter. This question, just now all the calculation, we use the perfect case. Ignore the air resistance, ignore the friction. But right now, this question is, yes, they tell you there is some losing. So they might be asking you calculate this, and then they're asking you how much energy is lost to the surrounding due to the friction. So you're using 160 minus the 120, then you know it's 40. So they can change their method to ask you, starting, okay, ending is less than 160 kilojoule. My final GPE only get 120 kilojoule. Why? Explain why. Because there is a friction, energy loss due to the friction. How much the energy losing to the surrounding? 160 minus 120, 40 kilojoule. Is that clear? Yes or no, dear? Okay, so like this question, for example, this question. Okay, my GPE is 0.016. My kinetic energy is 0.0015. They can add one more. C, asking you to calculate how much energy lost to the surrounding due to the friction, due to the liquid resistance. So you're just using the starting minus the final. I know that the rest is actually lost to the surrounding. Okay? So if no question, we goes to the lesson 20. Is it okay? Answer is 20 meter, this one. Okay, give me reaction. Then we continue lesson number 20. We still got 10 minutes, so we still can continue. Okay. Okay, energy resources. We have two types. Renewable, able to renew. That means that we can continue use and use and use. For example, water. Okay, it will not run out. Non-renewable, that means that after we use, no more already. For example, we burn the natural gas. After we burning, it disappear already. Okay, cannot be replaced. So that is non-renewable. Okay, so for renewable, there is a lot. So we give some example. For hydroelectric energy. Okay, hydroelectric energy. Then what else? Solar energy. You cannot say light energy at here. No, it's solar energy. Okay, geothermal also. Geothermal is using thermal, that means that heat. Geo is our earth. Heat from our earth called geothermal. We're using the heat from our core of earth to do something, okay, to generate electricity. That is called geothermal energy. Then what else? Biomass energy. What else? Wind energy. Wind all the times, okay, it won't be run out, okay. Then what else? Tidal or wave energy. Actually, these two is different. Tidal is the energy because of the attraction between Earth and Moon. Okay, Earth and Moon. Okay, non-renewable, after we use up, no more already. For example, the coal, okay, the oil, the natural gas. So these three we can call it as fossil fuel. Okay, and what else? Very important, nuclear fuel. Okay, nuclear energy or nuclear energy. Nuclear energy is non-renewable. Okay, nuclear energy we are using uranium or others. Okay, so you complete it. 30 seconds for you to complete it. If done, then give me response, then we are going to the next page. Angelina, okay already? Okay, we talk okay. No, means haven't. Okay, Zihua. Okay, Zihua, if you finish, you let us know. Okay, Dana. So at here, we talk about the first one, thermal power station. Thermal, that means that we're using the heat to do something. In order to generate electricity, the most important actually is we turn the generator. Turn generator. Okay, when we turning the generator, we will get electricity. But why? Why it turning, then it will generate electricity? This is your year 11 topic. Okay, year 11 we'll learn about that. Then after that, wait, where is my PowerPoint? Okay, here. PowerPoint here. Okay, so this one inside is a generator, slideshow, current. Okay, this one inside, the gray color is actually a generator, simple generator. So I turn it. So I will generate electricity. So we need to think how we turn generator. We can using wind turn the turbine, turn the generator. We can using water flow down, turn the turbine, turn generator. We can using others method, okay, whatever. So at here, where, how can I go out? Okay, so at here, turning, it's okay, we don't need to talk about how we turn it. Okay, so at here, we come back to our worksheet here. Thermal power station. How we generate electricity? We are going to turn the generator inside the power station. Actually, this is the whole part. Okay, how? We can burn something to produce the thermal, produce the heat. So how we burn? We can using the fossil fuel. Okay, we can burn the fossil fuel. So at here, the fuel can be the coal, can be the oil, can be the gas. We burn it, or okay, we using uranium, or we using uranium. Here we're using uranium for the nuclear reactions to be happen now. Okay, we burning the coal, oil, or gas, or we using uranium doing the nuclear fusion. They will producing thermal energy, burning something what, so you feel hot, you get the heat energy. Okay, then after that, so this one is talking about the structure. So we will happen at inside here. So at here is the burner or nuclear reactor. We produce the heat. Then we come here, we will have the boiler. Okay, the water will boil. Then water boil, it will become steam. Okay, water become hot because gain thermal energy. Then it will become steam. Steam, it will turn turbine. Turbines will turn generator. Okay, so at the end we get electricity. This is the whole process, the flow of generation of electricity. Yeah. Okay, so energy change. In this kind of question, they like to asking you the energy change. So starting is chemical energy. Okay, so the chemical energy, for example, the coal, the oil, and the gas, or the uranium also. Okay, uranium is nuclear energy. Okay, chemical energy. Then after that, we produce thermal energy. Okay. Then after that, we get kinetic energy. Kinetic energy is the movement of the steam. The steam is moved. Then after that, it trigger the turbine and generator. So it's also kinetic energy. Turns turbine and generator. Okay, final, we get electricity. So this is the energy change. Starting is chemical, then produce thermal, then we produce the kinetic energy. Turn turbine, turn generator. Final generator is turning, so we get electricity. Okay? If you finish, then you let me know. This is thermal. Okay, for the nuclear, if nuclear energy, so you can take some notes at here. Inside the nuclear reactor, actually is called nuclear fission reaction. Nuclear fission reaction. Okay, fission means that splitting. So we got one called uranium. This one year 11 we also learn again. So right now we just touch and go. Okay. So they were using one neutron. Neutron. Okay. It hit the uranium, then the uranium will split. Split into two smaller daughter nucleus. Okay. Plus neutron. Plus thermal energy. Energy lah. Okay. Energy. So at here, the energy is thermal energy. So for nuclear, we're using uranium. Using uranium, at the end, we're also producing the thermal energy. Then also the same, we heat the water. Water becomes steam. Steam become turning the generator and turn the turbine and turn the generator. So this part, in future we will learn. In future we'll learn. So is that clear for this part? Year 11 we'll learn. Crystal, okay, Yeah, touch and go. 500 500 RM. Okay, dear. Next. Okay, here hydroelectric power station. How it generate electricity. Okay, so water we store at here. So at here, water stored behind the reservoir. This one is GPE. Got certain height, we store it. So it will have a height, certain position. So for the water starting is GPE. Then water will flow. Okay, water flow, it will turn turbine, turn generator. So that is the things. At the end, we want turn generator only. Okay. So at here, rainwater flow off the hill into the reservoir behind the dam. So we store at here, store GPE. Water flow down the pipe from the reservoir to the turbine. Falling water turn the turbine. So we turn the turbine. Turbine turn generator. So electricity is generated. Okay, for this one, the most important, they like to asking you, what is the energy change? So at here, energy change is GPE. Water stored at the reservoir is GPE. Then water flow, turn turbine, turn generator, that is kinetic energy. Falling water, turn turbine, turbine, turn generator. Yes. Okay, can I continue to the tidal power station? Power station. Yes, okay, but before that, I remember that I got a video for this part. But okay, this is here. Okay, this one. Okay, here the black color inside actually is a copper wire. You see copper wire? It's actually white color is turbine. Then this one copper wire inside actually is a generator. This part is generator. This part is generator. I pour the water. Water will flow down through the straw. Straw will go in and hit the white color part, which is the turbine. Turbine will turn the generator. Then the LED will blink because we're producing the electricity. Okay, so I repeat one more time my explanation. So when the water flow through the straw here, then after that it hit the white color part, which is the turbine part, this part. Okay, then after that turbine turning, turbine is connected to the generator, so it will make the generator to turn also. So at the end we generate electricity. So here I connect my LED to the wire to the generator there. So my LED will blink because electricity is produced. Okay, then we finish a little bit here. Tidal power station. Tidal is a result of the moon and the sun. Okay, we don't want the sun, dear. Okay, it's the moon, gravitational. So here, no sun, no sun. Cancel the sun, okay, dear? Cancel the sun. Then it's built across a river where it meets the sea. The lake behind the dam will fill when the tide come in and then empty when the tide come out. So every day, actually got two times. So here, go out one time. Then after that, go in one time. Okay, so the flow of water will turn turbine. Turbine will turn generator. At the end, we get electricity. That is tidal. No sun, no sun. Okay, is that clear? Okay, Angeline, okay, Megan, okay, So it goes to the next page here. Wave. How about the wave? Okay, wave is moving up, down, up, down, up, down. So incoming wave at here. Water wave travel towards to the chamber. Okay, this part is the chamber towards. So water up and down in the chamber here, up and down. Air is pushed through. So here, inside here, got air particle. So when move up, then push it go. Okay, push through the turbine. So it will make the turbine turn, air particle, make the turbine turn, make the generator turn. So at the end, we produce electricity. So tidal and wave is different thing, different method to operate. Okay, so this one is wave. Geothermal, as I told you, geo is earth, our earth, called geo, earth. Okay, thermal is heat from earth. So at here, how it generate electricity is water is heated because this one is hot rock, okay? Our earth underground is very hot. Then after that, the water is heated. So at here, we got the water, hot water go up. Water very hot, it becomes steam. Okay, turn to become steam. Steam turn turbine, turn generator. Okay, turn turbine, turn generator, produce electricity. So many method at the end, we are how we turn generator, that's all. Using what method to turn. So this one is using the heat energy from our earth. Okay, until here, is that clear? Last, page 5. Megan, okay, Then here, solar energy. Solar energy is the electricity can be produced directly from the sun's radiation. Okay, so it can be from solar, from the sunlight. Then after that, we convert to the electricity. Okay, then after that, what else? There is another one more method. Is the design in this way: solar panel that used to heat the water. So the sunlight coming, okay, hit the mirror. The radiation will be reflected because this is a mirror, so it will reflect and then hit to the pipe. Pipe carrying water. They hit the pipe. Okay, radiation is reflected onto the pipe. Water in the pipe will absorb the energy. So water absorb energy, it will become steam. Okay, how water becomes steam? These two we already keep on mentioning. Steam, the turn the turbine. Okay, turbine turns the generator. Okay, at the end we produce electricity. That is another method.